Ever wondered how far we can push the boundaries of human capabilities with the help of technology? We're living in an era where technology is advancing at breakneck speed, and one of the most exciting frontiers of this rapid progression lies in the field of prosthetics. Prosthetics have come a long way from the wooden peg legs and hook hands of yore. Today, we're talking about high-tech solutions that can restore not just mobility, but potentially even the sense of touch. Yes, you heard that right, the sense of touch. Researchers at Stanford University are at the forefront of this exciting development, working on an electronic skin that could revolutionize the future of prosthetics. This isn't just any skin, it's a marvel of engineering that can convert pressure and temperature sensor signals directly into brain signals. It's like something straight out of a science fiction novel, isn't it? But it's not fiction, it's a reality. When connected to a rat's brain, this artificial skin induced movement in the animal's leg upon touch. It's a clear indication of the potential this technology holds for human use. The electronic skin is made from a thin and elastic material, making it adaptable to irregular surfaces like a human finger. Its design uses a smart circuit to transform sensor signals into pulse waves, which resemble commands the brain can understand. It's a language the brain speaks, and this electronic skin is becoming fluent in it. Improvements are still needed for medical use, but the prototype operates using significantly less energy than previous versions. This means it's cooler and more comfortable for prolonged use. It's a promising step forward for those with skin injuries, providing a comfortable and energy-efficient solution. Imagine a world where artificial limbs could feel and react just like natural ones. That's the future we're stepping into. It's a future where the lines between man and machine blur, and where technology can help us overcome physical limitations in ways we've only dreamed of before. And it's a future that's closer than you might think. Meet the researchers at Stanford University, who dared to dream and brought us one step closer to that future. These remarkable minds embarked on a journey to create something extraordinary, an electronic skin. Their goal was to create a technology that could mimic the sensation of touch, bridging the gap between robotics and the human experience. The road was fraught with challenges, but each obstacle was seen as an opportunity for innovation. The first hurdle was finding the right material. The team needed something that was not only thin and elastic, but also durable and adaptable. After countless hours of research and testing, they landed on a material that checked all the boxes. It was flexible enough to adapt to irregular surfaces, such as a human finger, yet resilient enough to withstand the demands of daily use. Next came the challenge of developing a mechanism that could convert sensor signals into brain signals. This was no easy task. It required a deep understanding of both electronics and neurology. The team had to design a circuit that could transform the sensor signals into pulse waves. These pulse waves had to closely resemble the commands the brain could understand. This was not about just creating a device, but about creating a dialogue between machine and mind. Lastly, the team had to ensure that the artificial skin was comfortable for prolonged use. They knew that no matter how functional the device was, it would be of little use if it was not comfortable. After rigorous testing and refinements, they created a prototype that operated using significantly less energy than previous versions. This not only made the device cooler to the touch, but also more comfortable for prolonged use. The journey was long and challenging, but the team's hard work and dedication paid off. They overcame each hurdle with determination and ingenuity, pushing the boundaries of what was thought possible. Their hard work and dedication gave birth to a prototype that's not just functional, but also efficient and comfortable. So, how does this electronic skin actually work? Well, let's take a deep dive into the nitty-gritty of this technological marvel. At the heart of the electronic skin's operation lies a thin, elastic material. This material is so flexible that it can conform to irregular surfaces, such as the human finger or the contours of an artificial limb, with ease. This adaptability allows the electronic skin to be effectively used in a variety of applications, including prosthetics. But the magic really begins when we delve into the inner workings of the electronic skin. The device harnesses the power of a specially designed circuit. This circuit's job is to transform sensor signals into pulse waves. These pulse waves are not just any ordinary signals, they are carefully calibrated to mimic the commands that our brain can understand. So when the electronic skin comes in contact with an object, the sensors embedded within the skin detect the pressure and temperature. These sensor signals are then converted by the circuit into pulse waves. These waves are transmitted to the brain, and voila, the brain perceives these signals as touch. But the story doesn't end there. The electronic skin is not just about sending signals to the brain, it's also about conserving energy. Unlike its predecessors, this prototype of electronic skin operates using significantly less energy. This means it stays cooler, making it more comfortable for prolonged use. Remember the rat experiment we mentioned earlier? Well, once the electronic skin was connected to the rat's brain, the animal's leg moved upon touch. That's right. The electronic skin was able to induce movement, all thanks to its ability to convert sensor signals into brain-compatible commands. So, in essence, the electronic skin is about transforming physical touch into digital signals, and then converting these digital signals back into a language that our brain can comprehend. This miraculous piece of technology can literally make an artificial limb feel and react to touch. But the journey doesn't end here. The prototype, while promising, still needs improvements. As we delve deeper into the realm of electronic skin, it's clear that there are still milestones to be crossed before this innovation is ready for medical use. One of the key areas of focus is energy efficiency. Previous versions of electronic skin were power-hungry monsters, heating up under prolonged use and causing discomfort. However, the Stanford team has made significant strides in this area. The current prototype operates using substantially less energy, making it not only cooler but also more comfortable for extended wear. Imagine a second skin, flexible and responsive, that doesn't make you break a sweat. But it's not just about being cool and comfortable. The lower energy consumption means the device can operate for longer periods without needing to recharge. This is crucial for potential users who would rely on this technology to perform everyday tasks. No one wants their electronic skin powering down in the middle of a handshake. In addition to energy efficiency, the researchers are also seeking to improve the device's adaptability. The current version is already impressively flexible, made from a thin, elastic material that can conform to irregular surfaces like a human finger. However, the goal is to further enhance this adaptability, allowing the electronic skin to seamlessly integrate with a wider range of prosthetic devices and body shapes. Moreover, the conversion of sensor signals into brain-like pulse waves is another area slated for improvement. The aim is to fine-tune this process, ensuring the electronic skin can more accurately mimic the commands that our brains understand. This would result in a more intuitive and natural feel for the user, bringing us one step closer to replicating the sensation of real skin. As we tread this path of innovation, it's important to remember that each improvement, each advancement, is a step towards a future where electronic skin can revolutionize prosthetics and change lives. The journey of innovation is a continuous one, and our researchers are committed to making this dream a reality. So, what does this mean for the future of prosthetics? Well, it means a world of possibilities, a revolution in the way we approach physical disability, injuries, and the concept of touch. This isn't just about a mechanical appendage, it's about a new layer of skin, an electronic skin, that could potentially change the lives of those with skin injuries. Imagine having a prosthetic limb that doesn't just move, but also feels. It's not just about making the movements, it's about experiencing the world through that limb, feeling the warmth of a loved one's hand, the coolness of a breeze, the pressure of a handshake. That's what this technology is aiming to achieve. This electronic skin is not just a piece of equipment, it's a leap towards normalcy for those who have lost a part of themselves. It's a thin, elastic material that can adapt to irregular surfaces, like a human finger, and it can convert pressure and temperature sensor signals directly into brain signals. The device uses a circuit to transform these sensor signals into pulse waves, commands that the brain can understand. So when this skin is touched, it sends a signal to the brain, just like our natural skin would. This isn't just mimicry of human skin, it's an emulation, a tribute to the complexity of our bodies. But the beauty of this technology isn't just in its function, but also in its design. It operates using significantly less energy than previous versions, making it cooler and more comfortable for prolonged use. This is a solution that is not just effective, but also energy efficient and user-friendly. This is the future of prosthetics, a future where artificial limbs aren't just functional but also sensory. A future where the line between the biological and the artificial becomes blurred, where technology doesn't just replace, but restores. The future of prosthetics is not just about replacing lost limbs, it's about restoring a sense of touch, a sense of normalcy. Thanks to technology, that future is closer than we think.